Voyager 1 was launched in 1977 with the goal of flying by Jupiter and Saturn to collect data on them. It was launched second but was faster than its twin Voyager 2. After it completed its flybys, it then crossed into interstellar space in August 2012. Voyager 1 is the first human-made object to venture into interstellar space. Voyager 1's interstellar mission began January 1st, 1990. The goal was to extend exploration to the outer limits of the Sun's sphere of influence and beyond. On March 5th, 1979, Voyager 1 discovered a thin ring around Jupiter and two new Jovian moons, Thebe and Metis. During its Saturn flyby in 1979, Voyager 1 found 5 new moons, a new ring called the G-ring, and complicated ring structures. It also photographed Saturn's new moons, Titan, Mimas, Enceladus, Tethys, Dione, and Rhea. All appeared to be composed largely of water ice. Images of Titan showed a thick atmosphere that completely hid the surface. On February 7, 1998, Voyager 1 became the most distant human-made object in existence when it overtook Pioneer 10. On December 6, 2004, Voyager 1 reached the termination shock and entered the helios sheath. On August 25, 2012, Voyager 1 became the first to exit the heliosphere and began measuring the interstellar environment. Voyager 1 is the first spacecraft to enter the heliosphere, the region outside the heliopause. It is currently in the constellation of Ophiuchus. For the first time since November 2023, Voyager 1 is returning usable data about the health and status of its onboard systems. As of August 23, 2024, Voyager 1 was 164.7 astronomical units from Earth, moving at a velocity of 38,026.76 miles per hour relative to the Sun. The Voyagers have provided us with new information and insights since their crossings over the boundary. Voyager 1's extended mission is expected to continue to return scientific data until 2025 with a maximum lifespan of 2030. Its RTGs may supply enough electrical power to return engineering data until 2036. Scientists learned through Voyager 1 and 2's data of their crossings that particles of solar wind and the interstellar space winds spill across the boundary. The wind from interstellar space is created by stars that went supernova millions of years ago. The mixing of these particles creates a layer between the heliopause and interstellar space. The interstellar magnetic field originates from stars that exploded, expelling not only material but their magnetic fields as well. The interaction between the Sun and interstellar space is also intriguing to scientists. Shockwaves released by the Sun can pass right through the heliopause into the interstellar medium and cause disturbances, much like supernovae from shockwaves that travel through the space between stars. All of the early knowledge gained from the crossings provides a complex picture of what happens between the Sun and interstellar space. This could be applied to all the stars astronomers study because they believe other stars likely possess the same features. As they study other stars with exoplanets around them, what they learn could be applied to other systems they discover. Comparing what Voyager 1 and 2 learned from their crossings provides interesting similarities and contrasts, as they provide two data points based on where they crossed into interstellar space. Scientists hope NASA signs off on an interstellar probe to gather more information and data. Thinking of the heliosphere like a windsock, astronomers would want a probe that could essentially travel down the tunnel created by the Sun's wind, extending the exploration boundaries of the solar system and the universe. That's the latest on the Voyager's journeys. I hope you enjoyed. Peace up.
A-Town down. Yeah, yeah. Okay.